Hello, ladies and gentlemen. We're going to do 7.2a today. We're going to be doing volumes of solids of revolutions. Our objectives are that we're going to find the volume of a solid of revolution using the disk method. And if you'll remember, there are several different methods that we can use, and we choose the method depending on what fits best with what we have been given. All right, so and remember, my day job is not drawing, so we're going to attempt to draw something that looks good, but it might not. So if this is my curve, okay, and we're going to call the height capital R of X, okay, and then this is going to be A, this is going to be B. This is my axis of revolution. Alrighty, and then just like when we had areas between two curves, I have a little rectangle dude that I am going to rotate around the axis of revolution. And then it would create a shape. So again, this is not my best skill in life, and I didn't draw any of the 3D images for you today, sad day, but you can either look in the book or you can do some imagining, because I really do kind of suck at it. All right, so what we're doing is we're taking this particular curve and we're going to rotate it about this axis. And if you think about what this makes, it would make, we might attempt to draw it. Oh, it's going to be yucky. It's going to make something that looks kind of like this. It's going to look kind of like that. And then here would be his center of his axis of rotation. Oh, isn't that beautiful? But the volume is going to be pi integral a to b of r of x quantity squared dx. So I want to kind of talk about what we're doing. So when I take this image and I rotate it about this axis, basically it creates a washer or a disc, which is, it has no holes in it, so we call it a disc and not a washer, but basically it's a circle, right? And it has some graduated circles, so it has some little ones and then they get bigger, right? Well, the area of a circle, so area of a circle is pi r squared, and if you'll notice, that's kind of what I have in my integration formula. Pi is a constant, so we pull that little sucker out front. My radius of my shape of my solid of revolution is going to be whatever this curve is, and it's going to be still going to be top minus the bottom, but because the axis of revolution is going through the image, that means that there are no holes, and so it's just going to be this particular equation, quantity squared. So basically what we're doing, and then before I say that, I'm going to show dx. The volume of a figure is the area of the base times the height, right? Well, this is going to give me the area of the base, and then this is going to give me my height. I think I said that right. If not, you get the general idea, because the pi is a constant. Here's the area of the base, the r squared, and then this is going to be the thickness. Maybe that's a better way to say that. So that's how I remember these formulas, because I'm really calculating the volume of a bunch of circles, right? So here's all my little circles. Let's pretend I can draw. And then here is my axis of revolution. So here are all of my little circles, and the radii are changing shape depending on where I am along the horizontal axis with my y. So that's kind of cool. Alrighty. So this process is actually not super difficult, okay? Well, then what happens if I take the same basic shape, right? So I'm going to draw this lovely little shape. We're going to call this C, and we're going to call this D. And instead of doing a vertical rectangle that I am revolving about the x-axis, what if the y-axis becomes my axis of revolution? Which means then that I am going to have my rectangle be going around. You still can't see my hand as I'm making hand motions. That always entertains me. So this is the the delta y, or dy, right? Well, now I need to do, technically what I'd be doing is right minus left, but again, the axis of revolution is going right smack through the middle of the image, okay? And I would now take this image and rotate it around. Ooh, let's see if I could do that. Maybe I can. Maybe it won't be too hideous. Okay. Again, there's my center, and then here's all my little circles getting smaller, and here, that's actually a symbol from all of my drafting experience for a center line. That's the axis of revolution. So it's not hideous. It could be better, but there you go. So then, on this one, my volume formula is still basically going to be the same. Here's the pi, because we're still talking about an accumulated area of circles, right? And I'm going to integrate this time from C to D, and I'm going to do the function in terms of y, quantity squared, put an extra little guy in there, dy. All right, so that's our basic formula as we start talking about the disk method, or if you think about it as a collection of circles. So for your first example, we want to find, sorry, these problems take a little bit longer to write in the beginning. Find the volume of a solid formed by revolving the region, so many words, bounded by the graph f of x is equal to, the square root of sine of x, that's cool, and the x-axis, which is nice. It means I don't have any holes, so it means it's going to be my axis of rotation. And I'm going to go from 0 is less than or equal to x less than or equal to pi. And I'm going to rotate about the x-axis. All right? So just like always, and I know I kind of cut off your viewing window, I'm always going to draw a circle. So the square root of sine means that I can't take the square root when sine, because remember my sine graph looks like that. And if I go from 0 to pi, which is halfway, then this is going to be my graph. Okay? So I'm going to draw my cute little graph. Here's the 1 because sine oscillates. That's really high. Oh well. We'll do that. Okay? This is going to be pi over 2. This is pi. This is 0. And since I'm revolving about, this is going to be not my axis of symmetry, but my axis of revolution. Since I'm revolving this little shape about the x-axis, then that means that I'm going to have a vertical rectangle, and I'm going to write a dx, which helps my poor little pea brain a lot, because then I have to think about which way I solve my equation. All right, so then my generic volume is pi, because we're talking about the disk method, and it's a collection of circles, and I'm going to integrate from 0 to pi, and remember it is the function, which is the sine of x, quantity squared dx. And again, this is kind of, this height, which is the function, is the height, or it is the radius of the circle, right? Then in our area formula, which you can't see anymore, so area is pi r squared, it's the radius squared. Well, in this particular situation, as I'm revolving my solid about the x-axis, the radius of the image comes from the curve, because that is the height or the radius. So then as I simplify this math, this is, the volume is pi, 0 to pi, and I have the sine of x dx. Okay, let me turn the handy dandy page so I don't do stupid things as I'm trying to do math for you. So then my volume is a negative pi, because the integral of sine is a negative cosine, and then I'm going to evaluate from 0 to pi. And at this point, I'm going to assume again that you're brilliant and that you can do that math. And when I do all of that, I end up with my volume is 2 pi. And so if I report politely, the volume of the rotated solid from 0 to 2 is 2 pi. And there we go. That was a pretty easy example. All right, for our next example, let's use a different colored pen because black is getting boring. We're going to find the volume of a solid formed by revolving, so much writing, the region bounded by f of x is 2 minus x squared, and g of x is 1, so that's a horizontal line, about the line y equals 1. So again, this is very nice because it means that the axis of rotation is right on the bottom of my image, okay? So we're going to draw a picture because a picture is worth 1,000 words. Alrighty, so 2 minus x squared, we've seen this little parabola before. That guy's going to be 2. And y equals 1, it's going to be right there. So this is y equals 1, and this is f of x, okay? So this is going to be the image that I'm rotating, and I'm rotating it about y equals 1, which is important because if I rotate it about the axis, the x-axis, then it would have a hole, and then that would be a different problem. So then if I draw my little rectangle, I still have a delta x because I'm revolving the area between the curves about this. So this is my axis of revolution. Okay, all right. So what I want to do now is kind of what we did in previous things. I want to find the points of intersection because I need to know where to integrate from, right? So I need A and B. So I'm going to set 2 minus x squared equal to 1, and I get a negative x squared plus 2 minus 1 is 0, a negative x squared plus 1 is 0, and then I get x squared is 1, and then I get x is plus or minus 1. So this is a negative 1, and this is a positive 1, okay? Alrighty, so the height of my object this time, because it's still in here, but because this isn't sitting on the x-axis, the height or the radius, so I'm going to write radius since we're talking about circles, is going to be f of x and then minus my g of x because it's not sitting on the x-axis. So my radius is going to be 2 minus x squared minus 1. So my radius is going to be a negative x squared plus 1. Alrighty? Okay? So, and remember, this is the radius, and so my volume equation, pi comes out front because he's a constant, negative 1 to 1. And then my r of x, so this is the radius, but it's also r of x, so it's going to be a negative x squared plus 1 quantity squared dx, okay? And I'm actually going to expand this, so just to help my poor little pea brain, I'm going to turn it around. So I'm going to have pi times the integral from a negative 1 to 1 of 1 minus 2x squared plus x to the 4th, use my parentheses, dx. And then if I do that math, and again, remember I'm assuming you're brilliant, you know how to integrate, then you're going to get that their volume is 16 pi over 15. Alrighty, and again, no units were given, so there's no units to report. Alrighty, I have 2 more examples for us, so let's do our next example. The next one says, find the volume, no kidding, of a solid formed by revolving the region about the y-axis. Ooh, new axis of rotation. Whew, and so much writing. So we're going to have x is equal to 0, y is equal to x squared, y is equal to 4, and y is equal to 9. So we're going to graph that before we do anything else. So here comes my handy dandy little graph. Y is equal to x squared is going to start right here. X is equal to 0, is right here. And then I have y is equal to 9. So this is y is 9. And then I have y is equal to 4. Okay? And we're going to revolve it about the y-axis. So my enclosed region is this. Okay? And I'm going to revolve it about the y-axis, which if you pay attention is actually pretty nice. See if I can scribble that in so it looks like a rectangle. Because if I rotate it about the y-axis, it's sitting on the y-axis, and so that's actually kind of nice. Okay? So this is my delta y. What it does also mean is that I have to solve this equation in terms of y. And because I'm over here, I'm only going to take the positive root. So I'm going to get x is equal to the square root of y. Okay? So now if I set up my integral for the volume, here's the pi. I'm going to integrate from c to d of my radius, r of y, quantity squared, dy. Okay? So here's the volume, here's the pi. I'm going to integrate from 4 to 9, bottom to top, and I'm going to have the square root of y, quantity squared, dy. So if I do that math, here's the pi, here's my integral, 4 to 9 of y dy. Again, super simple integral. You're brilliant. So the volume from 4 to 9 is going to equal 65 pi over 2. And you can redo your integration and practice doing that, which I highly recommend. Okay? But because we revolve our shape about the y-axis and the object is sitting on the y-axis, it's actually a really nice choice because it cuts out some of our math. All right, here's your last example. And I think, yep, it's pretty short. So we want to, of course, find the volume of the solid figure, that's a U, by the way, formed by revolving around the line x equals 2. So again, if we think about what we've just been told, and I'll give you more information, okay? But since we're revolving about a vertical line, in all likelihood, we're going to do a delta y, okay? So our region is bounded by, never know if bounded by or bound by is the correct grammar. Good thing I'm not an English teacher. Y equals x cubed, y equals 0, and x is 2. I'm pretty sure I'm going to have a dy, so I'm going to solve for x right now, and I'm going to have y to the 1/3. Okay, alrighty, and I am going to draw my image because, again, I think it's really important. So I'm going to have this cute little shape, y is equal to x squared. Here's the line, x is equal to 2, which means this is 8 because 2 cubed is 8, and you can't see all of my beautiful artwork. This would be 1. We're going to revolve this die about x equals 2. And this is my delta y. Okay, so this becomes my axis of revolution. Okay, I guess I should write axis of revolution so we don't think it's the axis of symmetry, which it actually is. And this is going to look really cool. And again, I could try to pretend to draw it, but it's going to look kind of like a Hershey's Kiss if you revolve it. So that's going to be your little Hershey's Kiss. That's awesome. And there's his lovely little axis of revolution going through our image. Okay. All right, so if I set this up, my volume is going to be pi because, again, I'm doing a collection of circles. I'm going to integrate from 0 to 8. My object is still sitting on the axis of revolution, which makes my life so much better. And I'm going to have y to the 1/3 dy. And again, you're brilliant, and I trust that you can do that math. So when you do that, you're going to get the volume from 0 to 8 is equal to 96 pi over 5. Because at this point, I think all you probably need me to do is to help you remember how to set it up. And again, I shouldn't quit my day job. Alrighty, that's it for today. I will see you soon.